Okay, welcome to the first video lecture, week one for Math 1325 Business Calculus. Today is January 12th, so the assignments will all open up on Canvas in the morning here. Okay, so what I have here is a copy of the textbook that we are using for this course. This is an OpenStax textbook, which means you can download the entire thing. I have separated it into the chapters that we're covering. We're covering chapters 1 up through chapters 4 of this textbook. So the first chapter here is about 66 pages long, and the first two sections are the content for week one. So if you look at your Canvas, I believe that the only thing it does not show you is it does not show you the assignment calendar, but looking at your syllabus, that's been uh, published for you. And then furthermore, you can log into the actual MyOpenMath directly. I think you can do it either way. I'm not 100% sure on that. Let me know if you have any problems with it. But you can log into the MyOpenMath website, and it will in fact show you the course calendar when all of the assignments are due. Now, keep in mind that the calendar only shows the due dates, so the due dates are actually on Sunday for this week, the 19th. So keep in mind 13, 14, 15, 16, and 17 is week one, and that will be sections 1.1 and 1.2. Okay, so straight into the content. Chapter one is a review of a lot of pre-calculus college algebra concepts. If you have taken college algebra very recently, meaning last semester, then most of this should be just kind of a rehash of what you do in a college algebra course. Now, depending on which particular instructor you had, I know a fair portion of what they do and how they do it, but this is going to follow a little bit more closely with chapter 1 and 3 out of the Pearson textbook, which I believe is the Lyle Hornsby textbook. I don't know what chapters exactly out of the OpenStax version of the textbook that we're using. Um, okay, so a couple of things. What exactly is a function? So a function is defined as a rule for any sort of relationship between an input, which is an independent quantity, and an output, which is a dependent quantity. So that's like an x and a y, where x is the independent variable and y is the dependent variable. This is a very high school algebra 2 definition. The um, important thing about a function is that it uniquely determines the output value. In other words, it is not ambiguous. When I plug in some number, say 5, it will give me a number that everybody can agree on coming out of the function. So it's not like I plug in 5 and I get both 7 and 19. There's no choice there. You get one number. That's it. That's important. Okay. Under function notation at the bottom of this first page here, we can write down, there's a couple of important components here to function notation. The first one, we have this letter, which is usually kind of a stylized, or to me, it always looks like it's italicized. Um, but you have a letter on the outside, which is like an H or an F or something, kind of like this stylistic letter. And then we have a parenthesis, and then we have a number or a variable or an expression on the inside of the parenthesis directly next to that. Now, what that means, it's the way that we read this is, for example, if we wanted to do find somebody's height based on how old they are, then we would say height is a function of age. In other words, the age that you're at uniquely determines your height. And then the way we could write this is h is a function of a, or h is f of a. We could write that as h is equal to f of a. So the way we read that f parenthesis a is f of a. And then most simply, we could just write it h of a. And that's actually where I wanted to start discussing this with you. So h of a, if you notice, the h is like a name. It tells me which particular function I'm going to use, and the a tells me what specific thing I'm going to plug into that function. Now, normally when we see this, we'll see like h of x or f of x, which is probably the majority of what you saw in college algebra, and we do that to avoid confusion. But it's important to know that if your terminal point was not college algebra, then you can have functions of a bunch of different variables. And so typically what this does is it says the function h depends on the variable a. It tells me what the variable that I should expect to see in this expression will be. Okay, so the notation, this is just kind of a summary of what I just said. If you want a more concise version of that, you look at the top of page 2. So let's take a look at tables of functions and kind of learn how to determine whether something is or is not a function based off of the input-output tables. So these are sometimes called two-way tables in like a high school Algebra 2 course. And we always have some kind of input value. Remember, that's like the independent variable, the variable that we're going to plug something in for. And then we have like an output variable. Typically, the input variable in high school algebra was x, the output variable was y. But I wanted to show you this example because the input here, if you recall up in the notation on page 1, it said that we have h is a function of a. So the output variable h is dependent upon the input variable a. And the fact that it is a function means that these should be uniquely determined. Now, if you take a look at this table, we actually have a non-example of a function. And I want you to think for just a brief second. You can pause the video and come up with what you think your answer is to this, and then resume the video when you're ready, and I will tell you what the answer is. But there is a reason in this two-way table why the specific quantities given do not represent a function. And I want you to take as a hint, it has to do with the uniquely determined portion of our definition. Pause the video, write down what you think your answer is, and then resume when you're ready. Okay. So the reason that this particular table does not represent a function here, if you take a look at it, we have a problem around age 5. So at age 5, we have that the height was both 40 and 42. So when I plug in 5, you have a choice. Do we want to talk about the age 5 where the height was 40, or do we want to talk about the age 5 where the height was 42? The excuse me. The important part here, the way that we can kind of quickly tell that this is not a function, and the way that I did it, I haven't actually looked at this example until today. And if you look at the input portion, the input line on your two-way table, you notice that every single input appears exactly once in the table, except for the input 5, which appears twice. Now, if 5 had appeared twice, but the output value was exactly the same, then what we could do is just remove the 5, at least in this context, because we're not dealing with like data points from a statistics course. We could just remove it because they're the same thing. But in this case, we have two different values for y, and the inputs are repeating themselves. So the fast, easy test for this, kind of the quick and dirty way to tell, remember, you always need to like actually check the definition, but if you want just like a really good way to guess, um, if the inputs repeat themselves, it's not a function. So let's take a look at this example 3, where we have a bunch of different input-output tables. We've got one on the left, one in the middle, one on the right. And it asks us to determine which of the following tables are representative of a function and then which ones are not. So if you look at the first leftmost table, we have 2, 5, and 8, and they map uniquely to 1, 3, and 6. So that means when we plug in 2, we get 1. When we plug in 5, we get 3. When we plug in 8, we get 6. And there's no weird issues with figuring out which thing goes to which thing. So there's no question that you have to ask about, now wait, do we mean this one or that one? So this is a function. It uniquely determines the output based on the inputs. In other words, the inputs do not repeat themselves. Same sort of thing with the middle. We have -3, 0, and 4, no inputs repeating. And if you look, we have 5, 1, and 5. So when I plug in -3, I should get 5. When I plug in 4, I should get 5. When I plug in 0, I should get 1. This one is worth mentioning because a lot of people from college algebra will make the mistake of noticing that the outputs repeat each other. And if the outputs repeat each other, that actually has to do with the function being injective, or in other words, invertible, as opposed to whether or not it is a function. A function who has repeating outputs can still pass the vertical line test. It just may not have an inverse because the outputs repeat. It does not pass the horizontal line test as a result of that. That's a requisite knowledge from a college algebra course. Now, if you look at the last table, we have 1, 5, 5, and 0, 2, and 4 as our outputs. So here we have a problem. The input 5 repeats itself twice, and furthermore, 5 maps to 2 and 5 maps to 4. So it maps to two different values. So if I said plug in 5, what do you get out of it? You say, well, I could get 2 or I could get 4. And that is the kind of situation that indicates that we don't have a function because it does not uniquely map 5 onto one of the outputs. Okay.